Welcome back. This is your final video. Yeah! Ooh, crowd goes wild. I don't think we'll do them next week because I'll be in town. Hopefully most of you will be as well. So this is your final video, and this is your midterm review. So you have a video for every single thing in Chapter 3, which is awesome. So you can always look back at Chapter 3 videos if you ever forget anything. So, which you won't because you're brilliant. So here we go, midterm review. Just so you know, this midterm review is going to run through a test from 2006. I put that test on Canvas, so if you want to follow along with those problems, you'll see some familiar problems from a unit test that was also from past years. Please do. So what I'm going to do here is I'm going to do a midterm from 2006 that covers the exact same content that we're covering. We are covering anything from chapters 1 to chapters 3. Please understand that this covers the same content, but it is not the exact same test. I'm not just going to change the numbers here. The test will look a little different in format. They'll be in different orders, but it covers the same content. You should be prepared to answer anything from chapters 1 through 3. So that is where we're at with this. So let's take a look at what this looks like. So my name is Key, and with period 6. And we move up, and so in this first page, it gave you some formulas. And now we're looking at the first problem. And the following samples are weights of 16 construction workers. Yes, 16, not 40, Ryan, just 16. And find the mean, the standard deviation, and the 5-number summary. I'm going to do this on my TI-89. So I put it into Stats List Editor, choose List 1, choose one variable stats, my mean is 169.5. My sample standard deviation is 11.1355. My 5-number summary is the min, which is 145, Q1, which is 163.5, the median, Q3, and the max. On to the next page. Alright, so they actually, on this page, is poor form, but that's actually the dashes for the 5-number summary, so I'll just rewrite them here. 145, 163.5, 171, 176, and 188. Find the mid-range. The mid-range is the minimum plus the maximum divided by 2. 166.5. Alright, and then it says, which is the correct box plot for the data set? Let's take a closer look at this. So, remember our minimum was 145. So if I look at this, 145, that's 150, 160, 170, 180. So that's 140. So we know that it cannot be this guy right here. Our Q3 was 176. So 176. So it can't be this guy. That Q3 is, excuse me, our median was 171. So it can't be this guy. That median is less than 170. So we eliminate that one right there. And then we have a maximum of 188. So that just leaves choice A there. So assuming there are no outliers, that's what it looks like. No, so that's the next question on this test. Are there any outliers? Let's find out. Remember the upper and lower fences. So to get the lower fence, we take Q1, which is 163.5. We need to calculate the IQR real quick. The IQR is Q3, which is 176, minus 163.5. So that IQR would be 12.5. So now our lower fence is 163.5 minus 1.5 times 12.5. Doing that math, and with 144.75 as our lower fence, our upper fence would be 176 plus 1.5 times 12.5. 194.75. There are no outliers. Nothing below 144, nothing ahead of 194.5. What percentage would fall between here? So we are going to use our mean this time. Take one of the endpoints, minus the mean, divided by the standard deviation. And we end up with 2.5. Take that 2.5 and put it in 1 minus 1 over k squared, 2.5 squared, and you end up with 84%. Moving on to the next problem. Let's match the following box plots to their corresponding summary statistic. Let's see what we got here. So, they all have medians of 50, and that lines up fine. Standard deviation, the biggest one has the biggest range. Looks like this would have to be box plot 1. It goes with A, because it has the biggest range, right? This one has a mean of 44, so that means it's pulled to the right a little bit, and it has a longer range, so this one would have to be 4, because the mean pulls this corner, right? The fact the mean is below means there's smaller numbers in the minimums, because the mean is below the median. This guy, they're all perfectly symmetrical. This guy right here is the only one that's perfectly symmetrical. And this one, our mean is above the median, which means we must have higher numbers up here. So in relative to the whole set, there's nothing pulling it down. So this guy right here goes right here, and that's 2. So 1, 4, 3, 2. Moving to the next question. In a unimodal symmetrical bell-shaped figure as shown in the figure below. Oop, that must be on the next page. There it is. What do we got here? Well, we know that it's like this. The mean, the median, mode all must be the same. It's unimodal, so mean, median, mode must all be the same. Part B. Right? Oh, these look familiar from our practice tests. Given the variance, what do we got here? We've got the root is the standard deviation. Variance, variance, measures volatility. It's based on the mean, and the root is the standard deviation. The root is the standard deviation. So take the square root, 1.2, and you'll get 1.09545, which rounds to this guy right here. Good job. Given the following data set, find the value that corresponds to the 75th percentile. Well, we have 1, 2, 3, 4, 5, 6, 7, 8. We need to order these guys. You can't do percentiles without ordering. 10, 14, 15, 23, 10, 14, 15, 23. Oh, I forgot 18. Let's see if we can put 18 in there. 18, 44, 56, and 72. Here we go. Now, 70th percentile would be 0.75 times 8 divided by 100. Do that math. You get 6. That's a whole number, so you're going to go to between the 6th and 7th one. 1, 2, 3, 4, 5, 6. Between the 6th and 7th one is the average of these two. And 50 is in the 75th percentile. Alright, so we want to find the sample variance and sample standard deviation for these numbers, and it says to show your work by hand. So, here's how you do it. First you take each number, 3, 13, 6, 20, and 7, and you calculate the mean. We're doing it by hand, so we're just going to go 3 plus 13 plus 6 plus 20 plus 7 by 1, 2, 3, 4, 5. So that's 20, 40, and 49 divided by 5. Just make sure I did that right. That equals 9.8. And then you take each one of these minus 9.8. So 3 minus 9.8, and so on. So 3 minus 9.8 is negative 6.8. Then 13 minus 9.8. And you're going to put the table by taking each one of these minus the mean. And then you square each one of these numbers. So, negative 6.8 squared is 46.24. 3.2 squared is 10.24. So once you get them all squared, then you add this column all the way up. So you're going to get the sum of all of these. So the sum of x minus x bar squared. You're going to add them all up. So that's what's going to be this number right here. So it's 46.24 plus 10.24 plus 14.44 plus 104.04 plus 7.84. 182.8. And since we have sample variance, we're going to divide that by n minus 1. So we're going to divide that by 4. So our sample variance is equal to 182.8 divided by 4. 45.7. Which means our standard deviation, the root is the standard deviation. Take that, 45.7, divide it, and you get 6.76018. There we go. And we showed all of our work to complete this by hand. I may not ask you to do this on a term yet, but you need to be able to do this for small sets. Some point this year, I am going to ask you on an assessment. Might not be on this midterm, but you need to know how to do it. So, and it might be on this midterm. Don't know yet. So here's our next page. Don't know why this kind of copied word, but such is life. Big white space up there. Alright, it says, we've seen this problem before. It says the bell shape, data, the mean of 871. You go one standard deviation way, you have 34% on each side. 2 standard deviations away, you get 95% total. Right, so this becomes 95% total. That means you get another 13.5% on each side. And then you go all the way out and you get 99.7%. So what do we have here? The bell-shaped data, standard deviation is 49. This is our mean in the middle. One of our boundaries is 920. 920 minus 871 divided by 49 equals 1. Go between 822, you have 1 standard deviation. This way you have 1 standard deviation. Looking at that middle region, That is 68% of the data. If a group has a mean of 65 and a standard deviation of 73, what interval should contain at least 88.9% of the data? Does it say anything here about being bell-shaped? And the answer is no, it doesn't. It doesn't say anything, so this is Chevy Chev. So, 1 minus 1 over k squared equals 0.889. You need to solve that first. F2 solve will do the trick on your calculator. And k is equal to 3.0015, but we're just going to round that to 3 on this guy. And now, if I go 3 standard deviations from 65, this is going to be quite a range. Mean of 65, standard deviation is 79.3. This is going to be quite a range. So, 65 plus 3 standard deviations, our upper value is 302.9. 65 minus 3 whole standard deviations, our lower value is going to be negative 172.9. So 88.9% of this data, whatever this data is, falls in this range right here. Okay, we're asking to construct a polygon. Polygons use midpoints on the x-axis and frequencies on the y-axis. So I need to calculate some midpoints. 29 plus 32 divided by 2 is 30.5. 32 divided by plus 35 divided by 2, 33.5. And I noticed something. These all go up by 3. This goes up by 3. So each of the midpoints are going to go up by 3. So I just have to add 3 each time. Now I'm going to draw a line right here. I'm going to draw a line right here. My frequencies go from 1 to 10. 4, 5, 6, 7, 8, 9, 10. There's 10. And this starts at my midpoints, 30.5, 33.5, 36.5, 39.5, 42.5, 45.5, that would be 48.5 if I kept going, so on. 1, 3, 6, 10, 8, 7. Connect the zeros, and voila, we got a polygon. Remember midpoints and frequencies. And we are done with this page. Move on to the next one. It's so fun. We're making great progress. Oh, this was the graph they wanted us to make the polygon on. We already did that, so we'll just make a big smiley face here. Woot woot. Love it. Loving it. Right. What is the mean and the standard deviation of this distribution? Well, we're going to put that in our calculator and take a quick look. Remember, when you do this, you're going to use F4. 1 for our stats. List 1 is the midpoints. List 2 is the frequency. And when it says list, you're going to put list 1 and list 2. The mean you're going to get is 40.1. The standard deviation you're going to get is 43.805. And then we want the z-score for a temperature of 32 relative to this data. So we're going to take 32 minus the mean divided by the standard deviations. This is going to tell us how many standard deviations away from the mean this is. We're going to get negative 2.00592. And that tells us that 32 is 2 standard deviations below the mean. Final question, I think. What type of graph is the figure below? Well, it's a bar chart. It is of categorical data in descending order. By golly, that's a Pareto chart. So this completes our review. What's not on here that I promise you will be on the midterm is a bunch of terms like systematic sampling, random sampling, stratified sampling, cluster sampling, discrete data, nominal data, ordinal data, ratio data. Those terms from chapter 1 will be on there. Knowing your symbols, that will be important for this guy too, so don't neglect that. Make sure that you go through your chapter 1 notes, your chapter 2 notes, and your chapter 3 notes. Look at past tests. Make sure that you have a note sheet that is comprehensive. You get 2 sides of 1 sheet of paper. 2 sides of 1 sheet of paper. You do not get multiple pages, Mitchell. Just 2 sides of 1 sheet of paper and your calculator. I know you guys are going to do great. I'm very proud of you for watching all these videos, and I look forward to seeing you all on Monday. Take care.